Hey there, and welcome to my presentation. My name is Anthony Lusardi, and today we're going to be talking about an API pet peeve of mine, and that's when APIs aren't really built for the people that are using them. But first, a little about me. This is my dog Asher, and he's normally the first thing that I tell people about myself. So there you go. But some other things about me. I've been involved in community building since I was a teenager. So shout out to New York Linux Users Group, which I joined around the age of 14 to 15. And it was actually a lot of fun at the time convincing my parents to let me go to the middle of Manhattan to this random floor in some huge building that I think was owned by IBM, and then to hang out with a bunch of nerds that I had met on the internet and never before in real life. And about 7 years ago, I learned that I could actually get paid to do this and do it as a full-time job. So I've done developer relations at a variety of places, most recently including Digital Asset, where I built my first community from the ground up, and Wix, where I planned and executed much of the community growth strategy from hundreds to tens of thousands of users. And now, most recently, at liblab, where I recently started, and we automatically turn your APIs into SDKs from open API specifications. And so I've worked with a lot of APIs over my career, and also so has liblab. And this is important because one thing I've noticed in my short time at liblab is that our clients actually have above average APIs. And I started wondering why that is. I think this might be partly because they care about their API design and open API specs and all the process and tooling that go into creating good APIs. And then I started wondering the converse of that. Why do so many APIs have design deficiencies? And I think one common thread that I've noticed for the rest of my career is that APIs I encounter often feel like they're made quickly. The core product is spec'd out, but the API often isn't. And this happens both when the API is the central interface to a product, like a SaaS solution, and especially in cases when it's not, when it's a secondary interface. And much of the time, APIs just look like a simple interface to the underlying data, which tends to cause problems because they generally don't consider how their users or their users will use them. And now that's a bit of a mouthful. Let me explain with an example. When I worked at Wix, we'd have users building websites with us, and they'd have their own users who are actually the people visiting their websites. And these were our users, and they were a core concern of ours. Ultimately, most of the developers using our platform, and this goes for a lot of platforms out there, we're going to be making products for other people. Every single one of our clients at liblab makes products for other people. And designing for these use cases is generally paramount. So are you with me so far? That's great. Now let's go ahead and focus on a specific scenario to really illustrate this issue. And a bit of a disclaimer before we get started, this is a broad strokes overview of a hypothetical API. You don't need to memorize it. It's only to get the gist of it, only the basics. And also keep in mind that while this API is hypothetical, APIs that behave exactly like this or in other ways that impact the customer and user experience negatively exist in the real world. So most APIs and their services look like this. You have the company that produces the service, their customer who consumes the API, and then produces some sort of application for their own users, be they external users out there in the world or internal users at their company. Somebody uses what the direct customer produces. And so the service that we're going to use that as an example is pretty straightforward. It's a SaaS solution for real-time text-based chat between users. You've got WebSockets for some real-time chat capabilities and REST API for everything else. Structurally, this all makes sense. And taking just this, the API looks great. It's also RESTful, at least by loose definitions of RESTful. There's no perfectly RESTful service out there. But it's RESTful in the sense that every operation is independent of other operations and it uses the proper HTTP verbs and standard naming conventions that you would expect. And so now we're going to be looking at the scenario where we're handling some user data related to profile photos and the chat groups that users belong to. So here we can take a look at the first API we have, and it's the user's profile schema. And we see everything that we'd expect. This is an interface for retrieving user data that very closely mirrors the actual backend database schema. Profile photo data is stored in the backend in another table with a foreign key linking them to users. That key, or ID in this case, is returned directly to the customers over the API. And then there's also an endpoint for which users are in which chat groups in this application. It's pretty simple and straightforward. And again, it mirrors the underlying data structure of the service. And so now you've got the customer. And they've built a successful group chat app thanks to this service. And the API and pricing in particular were perfect for them. They've got tens of millions of messages exchanged instantly every month with a very competitive cost structure. Tens of thousands of chat groups, and people are raving about it on social media and encouraging their friends to join. And then they got a feature request to add profile photos. This was always in the plan, but this customer wanted to release early and often. So their first versions that went a bit viral didn't include profile photos. But eventually users started asking about them, and the customer decided to prioritize this feature. And so an engineer starts working on a ticket. And they make a request to the /user endpoint. And they quickly find that there's no profile photo URL with a link to a CDN or something. Instead, they encounter another ID. So they check the docs, which say to get a photo ID from /user, and then make a request to /user/photo with that ID. That's not great, but the engineer can make this work. After all, they're only getting this for one user. And then they go ahead and query /user/photo and get a resource URL that points to an Amazon S3 bucket. And this makes sense, but there's a couple of things that are confusing for the developer here. There's no indication on if this resource URL changes or when it changes. When a user's profile photo changes, will this resource update or will there be a new URL? The docs don't say anything, and there's also no version ID in the URL, which you would normally expect for S3 CDN links. The URL string also appears to be random and doesn't match user IDs. So in other words, you can't construct these URLs from other user data that your client's application might already have, such as user ID. And that was, a bit of a headache, but overall, the engineer was able to work around the limitations of the API, and that's that, the end. Thank you. I'm just kidding, of course. A whole bunch of other stuff happened. A new ticket came in fact. And that new ticket says the engineer now needs to do the same exact thing that they just did. So they've already written most of the code for when a user joins to get all the profile photos of each member in a group for group sizes up to 256 users. And there's future plans to bump the group size limit even higher. It's at this point that the engineer starts reminiscing about lives they haven't lived, perhaps as a dog walker or an artist. I personally wish I could get paid to walk my dog that you saw on one of those early slides. And so now the engineer has a much more complex thing to create. They have a much more complex workflow. And in its worst case, this workflow, as you can see in that number at the bottom there, is going to require sending 765 requests to the API and to the S3 bucket whenever a new user joins a chat group. And it may get even worse if the group size limit increases. And remember that this isn't just tough from an engineering or customer experience perspective, but also a cost perspective for the customer. And it may be that calls to this API are very fairly priced, but if tens of thousands of chat groups start each incurring hundreds of requests every time a new user joins them, then those costs are going to quickly add up no matter how cheap it was for the customer. And so the engineering team starts coming up with mitigation strategies. They start investigating the docs to figure out if there's some way to just request a list of photo URLs. They start reaching out to the API support team to request features, but there's a backlog. They start measuring the response time to populate these low, typical, and worst case group sizes. They're considering reducing the maximum group size. Someone else shouts out parallelization and skeleton loaders, which were always going to be in the plan for the client's application, but the data still needs to be retrieved regardless. Someone else asks what happens if multiple users join around the same time? Can they make a lot more work for themselves and run their own cache of the provider's data? And finally, the worst outcome, especially for the service provider, is that they start investigating alternative API services. So what should have been a few simple tickets now involves several large staff meetings, potential architectural changes on the side of the user or the API provider, and the potential revenue loss of a spectacular client and promotional case study for the service provider. This is really, really not good. And so then the question is, how do we avoid this? And the answer is to build for all of your users. Build for their users, and even a few levels deeper, their users, depending on what service you're providing. You should know when you're building a service who all your users are. And so first, the thing to do is architect with intent. Build your API architecture not just to a RESTful standard, but to the ways you expect the marketplace to use it. This includes not just your API architecture, but your data architecture as well. Reach out to your product sales and marketing teams. They should already have some sort of market and segmentation analysis. Make sure you understand your target markets here. And make sure you're ready to iterate and even version your API when necessary. And think about the downstream. Very, very often, and I can't repeat this enough, your customers have customers or users themselves. Understand the common problems that customers are going to solve with your software, and identify what your users will have and what they may want to see in your software that your customers are building. Find their typical end users. And keep AI in mind too, with things like Model Context Protocol, which liblab now supports, and other interfaces between natural language and API-based services. It's now more important than ever for APIs to have a good user experience because it will translate to a good AI experience. An LLM is going to have a lot easier of a time with a simple call to an endpoint rather than having to handle a complex API workflow. And to leave you in these last few slides with some directly actionable advice on how to implement all this and how to approach all of this, here's a few things you can do. Number one, you can ask your users. You can ask them informally. If you have friends who work in one of your target markets, just reach out and say, hey, I'm building a new product and would like your feedback and thoughts on how you think people will use it. Even if they're just people you know on LinkedIn or on Twitter or something, you can go ahead and do that. And plenty of people will be more than happy to give you some of their thoughts. And make sure that if you have customers already, do quarterly surveys of them. Figure out where their gaps are. Ask them what they're hearing from their own users. See where their pain points are. Sometimes pain points like the one that I illustrated, they come up and the customer just decides they're going to move forward and they'll deal with that poor experience for their users. And it kind of falls by the wayside for them. So you're not just helping yourself build up your own products with these surveys, but you're helping your customers build up their products. And that just further strengthens your customer-client relationship with them. And make sure to also conduct structured user interviews with either your target market or their own target users. Focus your questions on things that are most likely to be impacted by your API here. So when you're doing your surveys, you don't just want to say, hey, how's it going? You want to come in prepared with questions, ready to ask why. And I have a bit more advice too. Make sure to dog food and use your own service if it's at all possible. But remember not to become complacent. Sometimes we use our own software and become so used to it that we start overlooking its rough edges. So always make sure that dog fooding leads to improving your software and doesn't lead to ignoring deficiencies in your existing software, which sometimes happens with the dog fooding approach. And build sample applications, build whole real applications against your API that you think your customers will build and that their users will use. They don't need to be perfect, but they should be much more than a demo or sales app. These sample apps are also great for anyone who wants to get started with your service. There's companies out there like Twilio and Stripe that actually do this very well. They build full-on applications that not only help inform themselves about their own API, but also function as great sample apps that any potential customer can use as a base to understand how to accomplish common tasks that people will do with their APIs. And if you can't fix some parts about the experience of your API, then you can encapsulate common tasks within SDK and at least improve your developer's experience. You can still face latency from multiple calls and some fragile workflows, but improving it here is at least a step in the right direction. And doing this not only makes life easier on your users, but it can also inform the design for the next iteration or version of your API. And if you want to make that easier on yourself, in particular, the generation of these types of SDKs, then reach out to us at liblab because we're more than happy to help get you there. And lastly, make sure that you use all the tools available to you. At liblab, when people use us, they will produce an open API spec, and then we will use that to generate an SDK. But open API specs go so far. There is so much tooling. There's so many API governance platforms out there. There's so many places that you can check out for tools to improve your workflow, to improve your API production. And they almost all take open API specs. So they're super powerful and great for making your API design just excellent. And so for real this time, thank you very much for listening to my talk. Once again, I'm Anthony Lusardi, and I work at liblab as a developer relations engineer, where we make it very easy to take APIs and automatically turn them into SDKs or client libraries for every major programming language. If you want to connect with me or liblab further, then you can check out the links on the screen, or you can scan this QR code. I'm also more than happy to chat about liblab, so if anything, my email is on the screen. Feel free to reach out. Thank you very much, and have a great day. Thank you for listening.